Welcome to the deep dive. Today, we're really digging into how to evaluate a Java software engineer, going beyond just the resume buzzwords.
Exactly. We're using this curated interview question guide as our source material.
Right. And the mission here is to pull out those really crucial, maybe sometimes surprising insights,
Yeah.
things that help you understand what real Java talent looks like.
Whether you're hiring, just curious about the field, or, well, a knowledge sponge like us.
Huh, yeah. So this guide covers both computer science fundamentals and specific Java know-how.
It does. And we want to focus on what truly signals a strong candidate within those areas, what really matters.
Okay, so let's dive in, starting with the bedrock. Yeah, computer science fundamentals.
Right, the core stuff.
And this guide we're looking at, it really emphasizes algorithmic thinking.
Hmm.
Like it prompts discussing basic algorithms, how candidates approach finding, thinking, sorting things.
Yeah, and that sounds like it gets right at their problem-solving process, their heuristics.
Do they jump to brute force first? Or look for efficiency? Can they talk about the trade-offs?
Precisely. It's less about reciting definitions, more about understanding, their thinking. How do they break down a problem?
What strategies do they use?
Exactly. And can they link those fundamental ideas to, say, database design or data modeling? That connection is key.
Makes sense. Knowing the theory is one thing, but applying it,
Yeah,
that's different.
totally.
The guide also hits on continuous learning, which feels, well, non-negotiable in tech today.
Oh, absolutely. You have to keep up.
It suggests asking about favorite tech books, who they follow on Twitter, blogs they read, that sort of thing.
And that tells you a lot about their learning habits, right? How adaptable are they likely to be?
Are they just passively consuming info, or are they actively, playing with new tech, joining discussions?
Yes, because the field changes so fast. That commitment to learning, it's a huge indicator of their potential down the line. It shows like a real passion, not just a 9 to 5 attitude.
And it connects to the next point, right? How are they applying it?
Mm-hmm. Practical engagement.
Yeah, the guide mentions GitHub activity, open source contributions, hackathons,
Tangible proof.
even side projects like game development. What really jumps out at you when someone contributes to open source? What does that signal?
Well, several things. Collaboration skills, for one. Being willing to put your code out there, get feedback.
That takes some confidence, or maybe humility?
Both, perhaps. And
Yeah.
often it shows real intrinsic motivation. They're doing it because they're interested. Those are qualities you don't always see on a standard resume.
Good point. Okay, shifting gears slightly, more specific tech topics. Threading models.
Ah, yes. Preemptive versus cooperative.
The guide brings this up. Seems pretty fundamental for concurrency in Java.
It is.
So just to clarify for everyone listening, preemptive means the OS switches threads. Cooperative means threads you'll control themselves.
Mhm.
Why does knowing this difference matter so much?
It's really crucial for understanding how Java actually manages concurrent tasks, how resources get allocated. If you don't get this, building efficient, stable, concurrent apps is, well, tricky.
Right, stability under load. Gotcha.
Mhm.
Another big one, continuous delivery. The guide asks about the tools, the practices,
CD, yeah. Automating the whole release pipeline.
getting updates out quickly, reliably. Why is this so central to modern development? Seems like table stakes now.
It really is. A candidate's answer here shows how familiar they are with automation, testing, the whole workflow needed for dependable releases. It's not just a buzzword.
Okay, and then there's the classic computer science question, the linked list cycle.
Ah, yes. How do you know if a linked list has a cycle?
It feels like a standard interview filter, doesn't it?
Yeah.
But I suppose it still tells you something valuable.
Absolutely. Sure, it's basic data structures and algorithms, but how they answer it.
Right. Do they just blurt out Floyd's cycle finding algorithm, or do they analyze the problem first? Think about edge cases.
Exactly. It shows their problem-solving approach in miniature.
Okay, that covers the CS fundamentals pretty well. Let's move into the Java-specific territory.
Sounds good.
First up, typing. The guide asks if Java is statically or dynamically typed.
Statically typed, of course.
Right, but it's not just knowing the term, it's the implications, isn't it? Early error detection, performance.
Understanding why it's designed that way, what are the trade-offs?
So what's the elevator pitch for static typing's benefit in a big Java project?
Basically, it's a safety net, catches type errors early, way before runtime, leads to more robust, maintainable code, especially when you've got lots of people working together. Consistency is key there.
Makes sense. Okay, next, common point of confusion, Argument passing in Java.
Pass by reference versus pass by value.
Yeah, I remember wrestling with this one myself. It's a bit subtle.
It is. Technically, primitives are pass by value, and object references are also pass by value.
Okay, so the reference itself is copied.
Exactly. But the key is whether the candidate understands that if you change the state of the object through that copied reference.
The original object changes too.
Right. Getting that nuance shows they understand memory and how objects interact.
Okay, building on that object interaction idea, the guide brings up abstract classes versus interfaces.
Another classic.
And again, it's not just listing the syntax differences. It's knowing when to use which one. That's the real skill.
Precisely. It taps into their understanding of OOP design principles. Do you need a base implementation, abstract class, or just define a contract interface? Especially given Java doesn't do multiple class inheritance directly.
Right, the what versus the how. And speaking of design, the guide mentions design patterns, specifically factory and singleton.
Good examples.
Why is knowing patterns like these more valuable than just, raw coding chops?
Because it shows they can think at a higher level of abstraction. They understand common solutions to common problems. It gives developers a shared language.
Reduces cognitive load when you look at code.
Exactly, and singleton especially. Implementing it correctly, considering thread safety, that can reveal a lot about their grasp of concurrency.
Interesting. Okay, another one that seems simple but trips people up.
Oh, yeah.
Versus the equals method.
And related. Shallow versus deep comparison.
It's all about object identity versus object equality, right? Are these two things the same?
Exactly. Understanding that difference is fundamental. Prevents nasty, subtle bugs.
And the shallow versus deep copy thing.
That tests if they understand object relationships. If you copy an object, are you copying just the references inside it? Shallow? Or the actual objects those references point to? Affects how changes propagate?
Gotcha. Okay, let's zoom out a bit. The guide asks about Java SE versus Java E.
Standard edition versus enterprise edition.
Yeah, for someone maybe not deep in the Java world, the distinction might be fuzzy.
Well, asking this gauges if they see the bigger picture. SE is the core language, the foundation. EE, now Jakarta E, builds on top of that with APIs for big enterprise-level applications.
Shows they understand the ecosystem.
Right.
Then there's exception handling. Runtime versus checked exceptions.
Crucial for writing robust code.
It's not just naming them, is it? It's knowing the philosophy. When do you use which?
That's the key. Checked exceptions force you to handle them try-catch or declare throws. Runtime exceptions usually signal programming errors, things you should fix rather than catch everywhere. Understanding that design rationale is important.
Makes sense. The guide also looks at Java's evolution. Key features in Java 5, 7, and 8.
Staying current again.
And it specifically calls out Lambda expressions in Java 8. Why were they such a big deal? A game changer, really.
Oh, huge. Lambdas brought functional programming concepts into Java in a big way. Made much more concise, readable, especially for things like elections processing. They enabled the whole Streams API, which is super powerful.
Right, changed how people wrote certain kinds of Java code.
Definitely.
The guide also asked candidates to pick a Java E API and describe it briefly.
Like servlets or JPA or JMS.
Yeah. Seems like a straightforward way to check if they've actually worked with enterprise Java.
Yeah. Exactly. You don't need encyclopedic knowledge, but have they used any key parts of the EE platform? Shows practical familiarity.
Okay, here's a very practical one. A 3-tier app freezes under high load. What are likely reasons? How do you troubleshoot?
The real-world scenario question. Love these.
Yeah, this feels like where experience really shows. It tests their diagnostic skills, right?
Yeah, absolutely.
Yeah.
Can they think systematically?
Oh,
Is it
yeah.
the database, the app server, network? What tools would they use? How would they isolate the bottleneck? It's about their troubleshooting process.
Moving towards more recent stuff, the guide mentions asynchronous support in Servlets 3.0. What's the use case there?
That was about handling long-running operations, like waiting for an external service or a slow database query without tying up a server thread the whole time.
Improve scalability, responsiveness.
Exactly. Especially for I/O-bound tasks, lets the server handle more concurrent requests efficiently.
Okay, nearly there.
Yeah.
Last one, multiple inheritance. Like class A extends B, C, possible in Java.
Nope, not directly for classes.
And the guide asks, why not?
The classic diamond problem. If B and C both have a method with the same name, and A inherits from both, which one does A use, it creates ambiguity.
So Java avoids that complexity.
Right. It uses interfaces to achieve a similar kind of polymorphism, defining contracts, but avoids the state inheritance issues of multiple class inheritance. Cleaner object model.
Wow, okay. We've covered a serious amount of ground there.
We really have.
So to kind of recap, evaluating a Java engineer isn't just about degrees or certs.
Definitely not.
You need to probe their grasp of those CS fundamentals, algorithms, data structures, and see how they think.
And assess their commitment to continuous learning. Are they engaged? Curious?
And look for that practical application. GitHub, open source, side projects, real evidence.
That's absolutely right. Passion, curiosity, practical skills. They often tell you more than formal qualifications.
And then for Java itself, it's drilling down into those nuances. Typing, argument passing.
Abstract classes versus interfaces, proper exception handling.
Knowing the important language changes like lambdas. It's about deep understanding, not just surface knowledge.
Exactly. Do they get the core principles and how to apply them? That's what you're looking for.
Okay, so here's a final thought for you listening. Java keeps evolving. The whole software world does. Beyond these kinds of interview questions, what do you think are the best signs of a candidate's long-term potential? Their adaptability for whatever comes next.
That's a great question to ponder. What signals true future-proofing in a developer?
Definitely something to think about, whether you're hiring or planning your own career. Thanks for diving deep with us today.